Irnich then created a second paper a year later looking at the same experiments to do with acupuncture and sham acupuncture. Now in this case it was a paired experiment rather than an unpaired experiment, so you don't have an experimental group and a control group. You have 34 participants that undertake a crossover study. So that means they're subjected to all of the different treatments, but in different orders. So some will start with the sham treatments, some will start with massage treatments, and some will start, well, there's sham acupuncture, dry needling, so correct acupuncture, and non-local acupuncture. So you assign them to 3 different pathways. So they can go through sham first, dry needling, non-local, or non-local first. This leads me to a problem with understanding the way they presented their results, because they're pre and post treatment VAS. Where is the pre and post treatment? Is the post treatment at the end of the study? Because if that's post treatment, everybody has had the same treatment. So how can you give a VAS score for post treatment for each of the different treatment types? The VAS is between 0 and 100 and modified to 0 to 10 as usual. And here I'm going to introduce this formula, which I'm going to use in general for combining standard deviations. So this is an unbiased estimator of the standard deviations when you combine them from 2 different groups. So you take the standard deviation of the first group, multiply it by n, the number of that first group minus 1, plus the standard deviation of the second group multiplied by the number of that second group minus 1, divided by the sum of the sizes of the 2 groups minus 2. This is an unbiased estimator of standard deviation. There are different ways you can combine standard deviations, but this is the way that I've chosen to use it within this study and within future studies. I prefer an unbiased estimate, so doing these subtractions from them, bring in the groups, it makes the standard deviation slightly larger than it would be if you did a more biased estimator, but it's not going to make it massively different. So when I take the experimental data, which they gave is the pre and the post numbers, and then I combine those 2 together to get a mean difference, and the standard deviation of the difference uses that formula. And that formula will be used in general to calculate all of the standard deviations of the differences where they're not provided within the papers. Not a very large placebo effect for the sham treatment, and not a very large effect for the deep needling. Large effect for the non-local acupuncture, which is a bit of a problem because the non-local acupuncture is actually not the treatment that I'm looking for. So the treatment is deep needling, the control is sham, and the actual massive effect is in the non-local acupuncture, which is not a comparable result to the other studies. As it says here, it's difficult which is the treated group. We have to stick with the deep needling, and the untreated group. The next paper in the list is Itoh's 2007. It's again an unpaired experiment, 40 participants with a dropout of 9. The participant flowchart is a bit of a mess as they go up and down. There are 4 treatments: standard acupuncture, trigger point acupuncture, non-trigger point acupuncture, and sham acupuncture. And it's taken over a 13-week time series where there's some upward movement and downward movement. The VAS scores are 0 to 100, so modified to 0 to 10 as usual. And the final time point is the one that I've taken for consistency with Itoh and Teles and the others. This is what I mean by the numbers going up and down. So you've got 1 dropout in the first column, and it goes from 10 to n equal 12. So that how does that happen? And then there's another dropout and it goes down from 12 to 10 and then n equals 8 at the end. I don't understand, but that's worrying. Here is the data table. So we have the number in each of the studies, 8, 8, 8 and 7 after the dropouts. Got the mean before. These are higher mean VAS scores before than in the other studies, and we've got the mean differences. So you've got standard, trigger, non-trigger and sham. Really, ideally here, the comparison is between standard and sham, although trigger is getting by far a much larger effect size, but I don't think that is comparable with the other treatments. So as I say here, trigger point acupuncture is the only one that gives a massive effect size. The rest of the treatments are very similar in effect size, and there's a small placebo effect for the sham procedure. It would be very easy to cherry pick the trigger point acupuncture for this study, as that's the only one that shows an effect, but that is not really fair. So you have to stick with the usual acupuncture so that you can compare one study to another. Studies, it becomes much easier to look at them and relate them to what you've seen before. Now I've got the Liang 2011 study, unpaired experiment, 190 participants, which is very large size, 12 dropouts, 5 from the study, 7 from the control. It's a simpler experiment with only control and treated. Control is the sham acupuncture. So you're seeing that the reports as we go down the list are becoming more standardized and easier to fit with the other studies, and it's easier to extract the data. Reports the values and not the differences, and so we need to use the standard deviation formula to combine the standard deviations for the pre and post to get the right values, and that was the formula that was in the Irnich 2002 data. So the baseline is at around 5, which is lower than Itoh but comparable to all the other studies. The standard deviations seem reasonable, 90 in one group, 88 in the other. The changes between the control, so the changes in the visual analog score, are 1.48 and 1.82, so they're very similar to one another. So the placebo effect is very close to the size of the treatment. The endpoint was chosen as the reported finish values, so that's after 3 months, not after 1 month, even though if you'd done an early stopping at 1 month, you'd have seen a larger effect size. You can't just take the largest effect sizes to cherry pick your data. You have to take it and make sure that you're consistent with the way you approach all of your files. From 2002, an unpaired experiment, 34 participants, 7 missed the final treatment. I think this was due to traffic or something like this. 5 from the control and 2 from the treated group. Sham acupuncture versus acupuncture, which is what we like to see. Reports the values and not the differences. So again, we need to use the standard deviation formula that I reported earlier in the Irnich 2002 study. And the scale needs modifying to 0 to 10 from 0 to 100. The control and the study have slightly different VAS baselines. So one is about the 5 that we're consistently seeing, and one is about the 6, which is a little bit high. Standard deviation is very high on the control, not so much in the study. 17 in both groups, consistency is good. The change is tiny for the control and much larger for the study, but again, you've got this large standard deviation effect. The placebo effect seems to be close to nothing, which is very different to other studies, and there seems to be some actual treatment effect. The endpoint is 9 days after final treatment. However, some of the participants missed that final treatment. So there is a little bit of doubt about those final results because of those 7 people missing. Sahin 2010 paper also follows pretty much the same way of recording as the other studies. So it's an unpaired experiment, 29 participants, 13 treated, 16 controls, sham acupuncture versus acupuncture, reports the values and not the differences. So again, you need to use the standard deviation formula that was in the Irnich slides. The only difference here is that there are 2 VAS scores, one for rest and one for movement. I've used the rest one because I think that is the one that is comparable to the VAS scores used in all of the other studies. Uses a score of 0 to 100, so it's modified to 0 to 10. The study baseline looks a little small. They're usually around 5, but the standard deviation on it is big. The only thing that's particularly special about this paper is that the VAS got worse for the acupuncture group than while it got significantly better for the control group. This is surprising and odd, but it is good news because this is an example of reporting a negative result. So the placebo effect in this case is, well, it's not actually so small, but the treatment made it worse. And as I said, most of the other papers don't record VAS score and in 2 different ways. Rest is most likely to be the same as the ones that were used in the other studies, and that's the one that I've chosen to focus on. The VAS paper from 2006 is fairly straightforward to extract the data. Unpaired experiment, 123 participants, 8 dropped out, 5 from control, 3 from treatment. That's not too different between the 2 groups. 13 lost to follow-up because they had quite a long gap between the actual final treatment and recording the follow-up measurements from the treatment group, and 17 from the control. A slightly larger difference than I'd like there between the 2 groups. Modified to 0 to 10, scale from 0 to 100. Now here you can see the difference in the sample sizes. So before you had 61 and 62, when you finish you got 45 and 40. Still a relatively large sample size. The change in the visual analog scale is very large for the treatment, and for the control is a reasonable size but much smaller. So this is probably one of the strongest evidence papers for the effect of acupuncture, and unlike Therethoteles, it doesn't have the same problems with dropout. So this is probably the most convincing evidence. The placebo effect is much smaller than the treatment effect. White 2004 is the last of the easy to analyze sets of data, which is simple to extract the data from. So unpaired experiment, 135 participants, 12 dropped out from the control, 16 from the treatment, slightly more from the treatment than you would like. The scales modified from 0 to 100 to 0 to 10. You can see the numbers there that go to 70 to 54 and 65 to 53. Again, I've used the formula to calculate the standard deviations for the differences, the same formula that I have in Irnich 2002. Here, the standard deviations are maybe a little large, and maybe there's a bit of an increase between the pre and the post. The effect size for acupuncture and control are effectively the same. So the placebo effect is pretty much the same as the treatment effect.